In this video, I'm going to show how to find the empirical formula from the percent composition of a compound, and then how to use the molar mass of a compound to determine the molecular formula. First, we need to understand the definition of an empirical formula and how it differs from the definition of a molecular formula. An empirical formula is the simplest ratio of atoms in a compound. The molecular formula, on the other hand, gives us the actual numbers of each type of atom in a single molecule of a compound. For example, let's look at the sugar glucose. The empirical formula for glucose is CH2O. However, the molecular formula for glucose is C6H12O6. So with the empirical formula, we have 1 carbon, 2 hydrogens, and 1 oxygen. For the molecular formula, we have 6 carbons, 12 hydrogens, and 6 oxygens. Both of these formulas have the same ratio of atoms, but in the case of the empirical, it's reduced to its simplest form of 1 to 2 to 1, whereas with molecular, it's 6 to 12 to 6. Now let's do a practice problem. A compound is composed of 40.01% carbon, 6.79% hydrogen, and 53.30% oxygen by mass. A. What is the empirical formula? B. If a molar mass of a compound is 180.16 grams per mole, what is the molecular formula? So first we need to convert these percentages of elements into grams. So the easiest way to do that is just assume that we have 100 grams of this compound. We can pick any arbitrary number, but 100 grams makes the math really easy. And we know that since we have 40.01% of that 100 grams is carbon, we can write that we have 40.01 grams of carbon. And we know for hydrogen we have 6.79% of that 100 grams, so we can write 6.79 grams of hydrogen. And we know we have 53.3% oxygen, which will become 53.30 grams of oxygen. Now we need to convert these masses of these elements into moles, and we can do that with dimensional analysis. We know that from the periodic table, the molar mass of carbon is 12.01 grams per mole, and we can use that as a conversion factor. For every 1 mole, it has a mass of 12.01 grams. We know to write it with the grams on the bottom because we want to be able to cancel out our units. Now we do the same thing for hydrogen. You know, for every 1 mole of hydrogen, it's 1.008 grams. And then for oxygen, it's 16 grams per mole. Our units will cancel on these as well. We'll be left with moles. Now I just need to type in the calculator, 40.01 divided by 12.01. And I get 3.33 moles of carbon. Now I'll do the same thing for hydrogen. 6.79 divided by 1.008 equals 6.736 moles. And then 53.30 divided by 16.00 will give us 3.33 moles of oxygen. So this is our ratio of atoms, but we want to get it to the simplest whole number form. So we'll want to divide by the smallest number, which in this case both of these are 3.33. So we'll divide all three of these by 3.33. And when I do that, obviously this will be 1. The second one will be close to 2. We'll round it off to 2. And for the oxygen will be 1. So now we know for our empirical formula, our subscripts will be these numbers. For carbon, we'll have 1 carbon, 2 hydrogens, and 1 oxygen. CH2O. So now that we have the empirical formula, we need to find the molecular formula. To start with, we need to find what the hypothetical molar mass of this empirical formula would be, and then compare that with what the known molecular formula's molar mass is, and then decide what multiplier will make our empirical formula's molar mass equal to the actual molecular molar mass. So to find the hypothetical molar mass of the empirical formula, we know that we have 1 carbon plus 2 hydrogens plus 1 oxygen. That's based on this formula. And from the periodic table, we know that the molar mass of carbon is 12.01 grams per mole, and for hydrogen, the molar mass is 1.008 grams per mole, and for oxygen, it is 16 grams per mole. And when I type this into my calculator, I get 30.026 grams per mole. And this is for the empirical formula CH2O. So now we need to compare this number to the actual molar mass of this compound, which is 180.16 grams per mole. And we know that again from the problem. They give it to us. And we're trying to find out what subscripts go here for the molecular formula. So the easiest way to do that is to divide this larger number by the smaller number, and this will help us decide what multiplier we need to multiply this empirical formula by. So I'm going to type in 180.16 into my calculator, divide by 30.026, and I get 6. So 6 times this number will give us this number, which means 6 times our empirical formula will give us our molecular formula. So we have 6 carbons, 12 hydrogens, and 6 oxygens. And this is our molecular formula. Let's try another problem. A chemist analyzes a pure sample of caffeine and finds that it contains 11.504 grams of carbon, 1.205 grams of hydrogen, 3.832 grams of oxygen, and 6.708 grams of nitrogen. The experimentally determined molar mass of caffeine is 194.19 grams per mole. A. Determine the empirical formula of caffeine. B. Determine the molecular formula. In this case, we do not need to convert our percentages to grams because they are already given to us in grams. So we know we have 11.504 grams of carbon, and we have 1.205 grams of hydrogen, 3.832 grams of oxygen, 6.708 grams of nitrogen. So now we need to convert these to moles. We know from the periodic table that for every 1 mole of carbon, we have 12.01 grams. Our units will cancel. We'll be left with moles of carbon. You type this into the calculator, 11.504 divided by 12.01, and the answer is 0.958 moles of carbon. And then we do the same thing for hydrogen. No, for 1 mole of hydrogen, 1.008 grams, and our units will again cancel. I type this into my calculator, 1.205 divided by 1.008, we get 1.196 moles of hydrogen. And then we do the same thing for oxygen. For every 1 mole of oxygen, we have 16 grams, and units cancel. Type this into my calculator, get 0.240 moles of oxygen. And finally for nitrogen, for every 1 mole of nitrogen, we have 14.01 grams. Units cancel, and when I type this into my calculator, I get 0.479 moles of nitrogen. So now we need to divide by the smallest number, which in this case is 0.24. So we're going to divide all of these by 0.24. And when I type that in my calculator, first one comes out to be approximately equal to 4. Second one is approximately equal to 5. This one is obviously equal to 1. And the final one is equal approximately to 2. Now these are our subscripts for our empirical formula. We have 4 carbons, 5 hydrogens, 2 nitrogens, and 1 oxygen. If you're wondering why I switched the order of oxygen and nitrogen, the convention is to write molecular formulas in alphabetical order. So now we need to figure out the molecular formula. So now we start with finding the molar mass of our empirical formula. You know, we have 4 carbons from our formula plus 5 hydrogens plus 2 nitrogens plus 1 oxygen. And we know from the periodic table that the molar mass of carbon is 12.01. Molar mass of hydrogen is 1.008. The molar mass of nitrogen is 14.01. And finally, oxygen is 16. When I type that into my calculator, I get 97 4.1 grams per mole. And this is our molar mass for our empirical formula, C4H5N2O. Now we need to compare this molar mass to the molar mass of caffeine, which is 194.19 grams per mole. And now we need to find our subscripts for our molecular formula of caffeine. The easiest way to do that is to divide our larger number by our smaller number to decide what multiplier we need to multiply our subscripts by. So when I divide 194.19 by 97.1, I get 2. So 2 times this will give us our molecular, and therefore 2 times our empirical formula will give us our molecular formula. So our final answer for our molecular formula is 2 times 4 C8, 2 times 5 H10, 2 times 2 N4, and O2. Now here are 2 problems that I would highly recommend solving for additional practice. You can post your answers to these practice problems in the comment section of this video, as well as any questions you may have about how to solve them. I will reply with an answer quickly. I wish you the best with your studies.